Hey everyone, welcome to another session of CeerazzleDazzlePhysics. In today's session, we're talking about nuclear decay equations, guys. So put down today's title, it's going to be nuclear decay equations. And before we get started, there's two things you've got to do. Number one, make sure you like and subscribe to keep my channel going. Turn on the notifications because I've always got new videos popping up. And also, guys, make sure you watch my other video on alpha, beta, and gamma radiation, guys, before moving on to this one here. Because in that video, I go over the properties of alpha, beta, and gamma. You need to understand that before looking at nuclear decay equations. Okay, getting straight into it. So, what happens when an element undergoes alpha decay? What happens when an element undergoes alpha decay? Well, let's have a quick recap before we get started. So, we know that an alpha particle, yes, it has two protons and it also has two neutrons. Two protons and two neutrons. And there we go, here's my proton, one proton here, another one over here, and I've got two neutrons over here. I can represent the alpha particle by having some notations. So I can put a 4 and a 2, and I can put the symbol for alpha here. So here is the notation for alpha radiation. As you can see, it's a 4 and a 2. Why is it a 2? Well, the bottom number is obviously the atomic number, which is simply the number of protons, And as you can see, guys, over here, I've got two protons, that's the reason why it's 2. The top number is the mass number, and if you've forgotten, the mass number is simply the total amount of protons and neutrons. So as you can see, I've got 1, 2, 3, 4. That's the reason why it is 4, because it is the total amount of protons and neutrons. So the mass number is going to be 4, the reason why I've got 4 nucleons in total. Right, so over here we have radon over here, Rn, and let's say it undergoes alpha decay. So we know that we have the radon here and it will break down. It will break down, and as it breaks down, it will release the alpha. So I can I can add to this diagram a plus sign here, and I can draw the alpha here. So now we have the 4, 2, and the alpha notation. Right, so obviously the alpha has flung off now. So what you're going to be left with is everything except the alpha. So this element here, it would actually be palladium over here. There we go. And obviously from here, the numbers we've got to talk about here, what will the two numbers be? Well, look, if the alpha is going to take 4 with it, and we had 219 at the start going in, then obviously this number over here must be 219 subtracting the 4 makes it 215 over there. And the bottom number, what will the bottom number be? Well, the alpha has taken away with it 2 protons, so obviously the bottom number will be 86 minus the 2, so therefore it becomes 84. Happy with that? Make sure you understand where those numbers have come from. So look, from there to here, obviously I've done -4. And from here to there, I've done -2. So the mass number decreases by 4 and the atomic number decreases by 2. Let's put that down. There we go, guys. I'll put it down here. The mass number decreases by 4 and the atomic number decreases by 2. And obviously, if you add them together, look, 215 plus the 4, that will be equal to the 219 over here. And look, the 84 plus the 2 over here is added up to make the 86 over here. So it's balanced out overall. Easy stuff, guys. So for alpha decay, it looks like this, guys. Make sure you're able to do the numbers yourself in an exam. Okay, so moving on now. What happens when an element undergoes beta decay? So if we have forgotten what beta decay is, a beta particle is simply a fast-moving electron. Fast-moving electron. And I'm going to represent the beta by drawing the symbol beta, and it's going to have the atomic mass of 0 because it's really, really small, but the atomic number is -1. The atomic number is -1. So you've got to memorize that. A lot of kids struggle with that because they're like, how on earth is that possible? Because there's no proton here. But you've got to accept it because obviously the electron has a charge of -1. So the beta is going to be 0 for the mass number, -1 for the atomic number at the bottom. And what happens in beta decay? Well, in beta decay, one neutron turns into a proton. Well, there you go, guys. As you can see, in beta decay, one of the neutrons, is turned into a proton and a beta particle is emitted. So you've got to memorize that, guys. So one neutron converts into a proton and a beta particle is emitted. So let's look at this carbon 14. I'm missing the 14 over here. Here it is, carbon 14. Let's say it undergoes beta decay. Well, we know what will come off is obviously the beta. So I can draw that over here. So I would say plus 0 minus 1, and here is the beta. There we go. That is the beta which has been flung off. So what is remaining then? What will remain? Well, look, we need to balance out for the mass number. They need to balance out. So this element over here, we'll just call it x for now. Look at the top number. I've got 14 over here, and I've got 0 over here. So what happens is this number will be 14. There we go. That number stays as 14 because 14 on the right hand side plus the 0 equals 14 on the left hand side. And look at the bottom number. The bottom number is obviously going to be, what number do I put there? What number do I put there? What number am I going to put? I've got the minus 1, I've got to make 6. So I have to put the 7 over here. So it's a 7 over here. So look carefully at what's happened here. We've had a 6, and look, as it decays, the atomic number goes up by 1 and releases the beta particle over here. So let's put that down. There you go, guys. I'll put it down at the bottom. The atomic number increases by 1. Look, it goes from 6 to the 7. And look at the mass number, though. The mass number remains the same. So the mass number remains the same. In this case, it actually makes nitrogen because obviously it's changed. It's become a new element over here. As you can see, guys, it's become a new element. Why? Because the atomic number has changed. It's gone from 6 to 7 here. So the atomic number has changed. Therefore, we have a new element. And obviously in the alpha decay, there's also a new element because the atomic number changed. So if the atomic number changes, we get a new element being formed. Okay, so you're probably wondering what happens during gamma decay. So what happens during gamma decay? Let's have a quick recap. So for gamma, we know that gamma is an electromagnetic wave. There it is. I've drawn it as a symbol over here. And the symbol for gamma is going to be this. That's a symbol for gamma. But because there's no atomic mass or atomic number, we will put 0, 0 over here. So let's say we have carbon 14 and it undergoes gamma decay. I'll add it over here. So the gamma comes out, it's 0, 0 now. What are the numbers of the element which is remaining? Well, obviously, have a look. They're going to remain the same because it's going to take 0 from the 14 and 0 from the 6. So therefore, this becomes 14, it remains, and the other one remains as 6 over here. So this one, look, it did not change element. It did not change element. It is still carbon 14, 6. Because obviously the gamma is just a burst of radiation. So there is no change here for gamma radiation. There you go, guys. I've put it down at the bottom. There is no change in the atomic mass or the atomic number. And therefore there is no new element created, guys. There is no new element created. Okay, so let's test our understanding of what we've learned so far today. So, fill in the missing numbers for alpha decay. So we have uranium here. What are these two numbers here? Give you a second, guys. Pause the video if needed. Okay, so hopefully you can identify that. Obviously, we need to add this 4 plus a number here must be equal to this number here. So this one is 230. Yes, happy with that because 230 plus 4 is equal to 234. And look, the 90 is over here. So this must take the 2 with it over here. 2 marks, easy stuff. Wonderful stuff, guys. Beta decay now, for beta decay. So give you a second now to solve this one as well. Right, so for beta decay, have a look, guys. So we're going to change the numbers now. Beta decay, we know it's 0. We also know it's minus 1 at the bottom over here. And obviously 0 has gone with the beta. This must remain as 25. And obviously, now looking at the atomic number, it's minus 1 for the beta. What number do I put here? What number is that going to be? Well, I know it's going to be over here. This one is going to be 12. 12. Make sure you understand the reason why, because look, the 12 here plus the minus 1 will give me the 11 over here. Easy stuff, guys. Okay. Alright, so right from the top, our today's title is going to be Nuclear Decay Equations. And then I talked about what happens when an element undergoes alpha decay. Well, we know an alpha particle is 2 protons and 2 neutrons. If radon undergoes alpha decay, have a look at the numbers. You'll be left with an element which is minus 4 for the atomic mass and minus 2 for the atomic number. So look, guys, what happens is the mass number decreases by 4 and the atomic number decreases by 2 if alpha emission occurs. And obviously you get a new element because the atomic number has now changed. Then scrolling down, guys, we then talked about beta decay. So for beta decay, we know that 1 neutron is turned into a proton and the beta particle is emitted. And obviously the symbol now is 0, -1 and the beta symbol. Look, if we have carbon 14 and it undergoes beta decay, what happens is the mass number remains the same, because look, the 14 remains the same, but the atomic number goes up by 1. It goes up by 1. Loads of kids struggle with this because they can't really understand why is it that the atomic number has gone up by 1. But obviously, think about it. The beta particle is 0, -1. I've got to balance it out. That's the reason why the atomic number goes up by 1. Always remember, from beta decay, 1 neutron turns into a proton. That's the reason why this works. So look guys, the atomic number increases by 1, but the atomic mass remains the same, and a new element is created. Why? Because the atomic number has now changed. Then scrolling down, we talked about gamma decay. So look, in gamma decay, in 0, 0, there's no charge, nor is there any atomic number, and therefore there's no change for the element. So it looks like this, it remains the same as before. There is no change in atomic mass or no atomic number change, and therefore no new element is created. And that's it for another session of CeerazzleDazzle Physics. I hope you enjoyed today's session. Make sure you like and subscribe to my channel to keep me going. Turn on your notifications, guys. Anyways, ciao ciao and good luck in your studies. Goodbye.